Hey there, this is Idan and welcome to Quantum Linear Regression for Developers. This will be a hands-on guide into writing code for quantum linear regression in one day. This is all it is supposed to take you if you put in the work. This course is designed for anyone who wants to write the code for quantum linear regression but doesn't want to go too much into the details of the mathematics behind it. The thing is, you don't really need the mathematics, even though it's being taught in most linear regression and machine learning courses in general. Not only that, but since we're going to skip the math, we're going to be able to go much further and not stop at basic linear regression, but deal with the quantum version of it, which is the most advanced version of linear regression there is. Now, linear regression is the most basic and fundamental technique in machine learning, and even more complex techniques like deep learning and stuff like that have linear regression as their key element, so you can't skip it. Not only that, but more often than not, you don't need deep learning and stuff like that, and linear regression is going to be able to do the work beautifully and much faster. So let's see what it is exactly. So this is a typical visualization of data you might find in linear regression or machine learning in general. And in this case, we can clearly see that there is some clear relation between P and W. And for now, don't worry about what P and W stand for. But the thing is, we want to be able to measure W and predict P using W. And the task for machine learning is finding the rule that relates P and W. And basically what linear regression is going to do is it's going to draw this line, okay, that goes somewhere in the middle here, and will enable us to measure W and relate it exactly to P. So this line might be something like P equals 3 times W plus 2. Which means that next time, when we measure W, in order to get P, we just multiply it by 3 and add 2. Okay, so let's say that you're a doctor, and you suspect that there is some relation between the weight of a person and his blood pressure. And you want to be able to weigh someone and predict what his blood pressure would be with good precision. Now, why not just take his blood pressure? This could be, for example, because weighing someone is a very cheap test. You just put him on the scale, whereas taking someone's blood pressure could be an expensive procedure. So you have a motivation for just weighing someone if you can get the blood pressure for free. Now here, as we saw in this data set, now we can see that P is just blood pressure and W is weight. We have this nice relation. And the thing is, whatever model you're looking for, start with the most simple form there is. Okay, so this is rule 1 in machine learning in general. So the most simple rule is, let's say that blood pressure is just some number, A is a number, multiplied by the weight. Now I will just give you an example of how you can overcomplicate stuff. Then you can guess that the blood pressure is the logarithm of the sine of A times W plus B. This is very complicated and you should never ever go there. Definitely not at the beginning. Now let's say we had a couple of people coming in the lab and we had 5 people here. We weighed them, and for each person we took his weight and his blood pressure. At the beginning we have to take blood pressure in order to teach the machine, the computer, how to find the rules that relates weight and blood pressure. Now the key element is going from these lists into something called a vector, or in some programming language this is called an array or whatever. The thing is, when you go into a vector or an array, you allow your programming language to manipulate these quantities quite easily. So let's just write it down like this. Okay, so how did we get W? Okay, this is just this list. We moved it, we wrote it like this. And this list, the blood pressure, is this one, okay? Now, W is called a vector, and P is just another vector. Now the problem is, this vector, which we called P, is equal to A times this vector, which we call W. And the problem in linear regression is how to find A. And in the next video, we're going to find A and show that it's really simple and nothing to be afraid of. See you then.